Hello everyone, welcome to this session. My name is Zhenyu Zheng. I'm from Huawei. In this session, I would like to have a brief introduction about the ARM data center ecosystem landscape. It is a centralized information hub for all ARM developers. Maybe some of you have already heard about it from the keynote. It is a part of project we are currently pushing at the Leonardo LDCG group to provide a centralized information hub for ARM developers, users, and upstream project maintainers. In this session, I will talk about some of the stories behind this project. I think this bar chart may have already been shown in a lot of places, and might have heard of the stories about it quite a lot of time in today's events. But here I will still use this as the beginning of this session, because the number is really amazing. From this graph, we can see that the shipment for ARM chips have boosted in the last few years, from 6.1 billion per year at year 2010 to 25 billion per year at year 2020. One of the reasons behind it is, and could be known to most of the people, could be the rapid growth of the smartphone usage. But there are also another reason behind it, especially for the last few years. It is rapid growth of the ARM chips usage in the data centers. In the past few years, many vendors and cloud providers start to provide ARM-based data center chips and virtual machines. The most famous one could be AWS Graviton 2 virtual machine, the Ampere Alta, and the Huawei Kunpeng CPU. All of them have shown quite obvious advantages in performance and costs in many data centers' major use cases and workloads, such as big data services, web servers, and containerized microservices, cache fleets, and distributed data stores that can be spread across multiple cores. According to this, more and more users start to considering using ARM-based CPUs in their data centers. With more users start to considering the software ecosystem on top of those brilliant data center software becomes more important. Since open source software is most popular software development method and workflow nowadays, many users use open source software in their business, and many commercial software also builds on famous open source software. So we think that work on making open source software be able to running on ARM and run better on ARM could be the most productive way to enrich the ARM data center software ecosystem. And from this graph, we can have a clear view about the whole software stack. From the end user's perspective, they may only care about the top-level applications. For example, big data user may only care about the end-user big data software, like Hadoop and Spark. They does not care more about the infrastructure layer beneath, like OpenStack and Kubernetes as the cloud infrastructure layer, and which operating system the cluster is using. This might not affect the result or experiences of the user case, but is it? I think the answer is not. Every component of the software stack is actually very important to the overall user experience and the result to the user case. The hardware needs the operating systems and libraries to release the hardware's special features. And in the cloud era, the cloud and cloud-native infrastructure is for sure the mandatory to make the management more easier, and then is the middleware, the database, and the user application softwares like big data, web, and artificial intelligence. Even a small and very basic library can make a lot of difference for the user. Here I have a very interesting story. After working on a lot of projects, we found out that in many applications, the key to boost the performance sometimes goes all the way down to the programming language itself, especially for applications written in languages like Java, Scala, and etc. in those programming languages. The program runs on VM runtimes, like JVM. So there is a middle layer between the application and the hardware. This is good to make the application more adaptive for different hardware. But sometimes it blocks you from perform attenuations for specific hardware. And sometimes the newer version of the programming languages, the newer hardware platform, it have better support. After added ARM-CIs for Spark, Flink, and Hive, we observed that among all the tests, some of the mathematical calculation tests have different results on ARM and x86 hardware. After looking into it, we found out that the root cause for this is because the mathematical calculation library in Java supports dynamic replacement for different hardware platforms. And in Java 8, x86 has an accelerated implementation which runs faster, but the mathematical accuracy is not correct. In Java 11, Java ARM platform also added this corresponding acceleration, and it provides both faster calculation while maintaining the mathematical accuracy. So simply using the newer version of Java in your application can provide a better performance. And this story proves that even a little math library in different Java version on different architecture could make a big difference in the end user's experience. Here, I have transformed the previous graph to a more detailed list with the open source project names that we are listed out to be the most widely used ones in each layer and area. I think everyone could recognize some projects that could be familiar with. This could be only a small part of the open source projects all over the world, but the number already reached 200 and more. I'm listing them here to give the audience an overall look at the works items to be make the ARM data center have a better software ecosystem. And obviously, this is not something a small group of people could do. And it is also the reason behind the promoting actions I've been working on the past 2 years and the initial idea behind the landscape project. We want more people to join to work to make a better software ecosystem. If you are interested to join the work, one thing you can do is to add the ARM-CIs to the upstream project that you are interested. In this it is the first step we always do. Here, I will show you why it is very important. In a typical open source development workflow, when a contributor wants to contribute some codes to a project, he or she has to write the codes, build and test the codes on their local development environment. After everything is checked, he or she can then push the code to the upstream project repository, for example, on GitHub. And the codes will also be built and tested there too. And if everything okay, the code might be merged to the mainstream. And after a certain period of time, the project might release a package that could be easily for user to use directly. And those tests and workflow guarantees the quality of the project. Since x86 is a major product on the market and continuously high quality contributions from x86 users and vendors, the majority of open source projects, the workflow is based on x86 platform. So for x86 users, the quality is good for sure, but for ARM users or users in other platforms, there might be some problems, as the workflow does not provide the build and test on those platforms. In order to provide a quality assurance on ARM platform, the first thing we always do is to propose to add ARM-CIs to the development workflow and run the same test to achieve the same quality for ARM users. And that's exactly what we did. With the strategy and work just introduced, we have already enabled a lot of open source projects in the past 2 years, covering the majority of projects on the list I have listed. We think it could provide a very good ecosystem for users, developers, and community maintainers. But we still observed many gaps. Here I have some examples. First, from the user's perspective, as a user considering to using ARM in my business, I may want to know whether the software I'm interested in supporting ARM. And if it does, which version of this software supports ARM? As when we add support to a software, we always add it to the development branch. And people not always using the latest version, or should I say, almost no one uses the latest version. So the user should know about the version that supports ARM. The next important thing user cares about is how does the software perform on the ARM comparing to their old platform. And are there any guides or best practice about using this software on ARM so they can have a better understanding? And if a software does not support ARM yet, what is blocking the software being supported? Are there anyone working on solving problems? How long could it be expected to have ARM support? I believe those could be typical questions for a user that could ask before switch to ARM platform. Currently, if I want to know any of this information, I may have to search and browse a lot of web pages to find out the answers. Next, from the contributor's perspective, there are also a lot of things that cares about. For example, if I'm a contributor that wants to enable some software on ARM, the first thing I want to know is, are there any other contributors also interested in making this software to be able to work on ARM? If there are someone else also interested, and if we can cooperate, it could be much easier. As the open source project maintainers will always judge the priority of the proposal based on how many people want it and how many people are willing to work on it. Another thing I would like to know is, have this proposal been proposed to the project before? If have, what is the attitude of the project maintainers? Why does it not happen? Is it because of the objection from the maintainers team due to some reasons, or just because no one actually works on it? This could makes a lot of difference if you propose to add ARM support again to this project. And if there are some previous work, what are the current status? And are they have any blocking issues? Currently, if a contributor wants to find out those answers to the above questions, he or she also have to check a lot of histories about the project, like the mailing list, issue history, and this could also cost a lot of time. It is also quite challenging from the community maintainer's perspective. Providing support on a brand new platform could cost a lot. They may need to put people maintaining it, and there could be also resources to put into it. So they might want to know a lot of background information and details about ARM in data centers. Typical questions might include the current status about ARM in data centers, and how many softwares, or more particularly, in related areas has already supported ARM. And more important questions could be, how many users are behind this request, and how many works need to be done to support it. Who would like to work on it? Other questions could be, who will maintain the ARM branch, and where could they get resources for testing and development? All those questions could provide a very good look about the benefits versus cost about adding ARM support to the project. Here I have an example about how long this could be taking to make the upstream maintainers have a good understanding on those questions and made the decision. I will use the timeline we added ARM support to Apache Hadoop as an example. We started the initial proposal and discussion about the request at June 2019, and the maintainers have a lot of questions. Some maintainers does not even know the ARM can work on data centers and still thinks that we are talking about running Hadoop on Raspberry Pi devices. So we spend a lot of time introducing the background information and the status about ARM in data centers. For this, we did 2 to 3 rounds of discussion with a wider and wider crowd of maintainers, from general information to ARM CI implementation details. And finally, we got a good understanding and resulted about it. This took us about 4 months. On January 2020, we have finally set up the ARM CI in Hadoop upstream. And after 6 months of stable running and fixed few bugs, the Apache Hadoop community released their first ARM-supported version. The overall time cost from the initial proposal to the ARM release is over a year, which is quite long. And when we start our proposal to other projects, we could be doing the same process again. It might cost a fewer time, but in my experiences, it still needs few months. Why it costs so much time? I think one of the reasons could be that we lack of a unified information hub for users, contributors, and upstream maintainers to quickly find out the answers and background information about the questions they want to know. In order to solve this problem, we start to make a unified information hub which includes a landscape for ARM-supported open source project and a communication hubs for users, contributors, and upstream maintainers to perform instant discussion about their request. We have already made a demo landscape site. The landscape currently covers over 100 famous open source projects that already have ARM support. We separated them into different areas, like the cloud infrastructure, big data, database, web, libraries, and AI, and Exactly. I think this could provide a very good view about the current status of the ARM data center in a very quick peek. And if you click the logo of the project, you will be able to find out much more information. Let's take the Hadoop as an example. If you click the logo, it will jump to a project details page. From project details web page, we can see quite a lot of information, such as which release does it support ARM, and users can jump directly to the download page of this version by clicking on the version number. The project also provides live status about the upstream CI itself, and the user stories and the work items related to ARM support. This could include work in progress items and already done items. In this example, all the works items are done, so if you are not using the versions that already have the ARM support releases, you can check out the work items and try to backward them to the versions you are using. If they are working in progress items, you can join the work and put them together. I think the landscape and project details website could provide very good information for users, contributors, and upstream maintainers and save a lot of time while in the whole process. Currently, we are discussing with the Linaro team to make this project an official Linaro project to attract more contributors and to build this information hub together. To make the life of the participants of the ARM ecosystem much easier, feel free to contribute to this project and build a better ecosystem together. Thanks a lot.